When we say that atoms are mostly empty space, it sounds like a clever scientific phrase, almost abstract, but its implications are deeply unsettling once you allow the idea to settle in your mind. Everything you see, touch, and trust as solid your body, the floor beneath you, the walls around you, even the mountains and the planet itself, is built on structures that are overwhelmingly void. This is not poetic exaggeration. It is a literal description of reality at its most fundamental level. To grasp this, imagine shrinking yourself down to the scale of an atom. What you would expect, based on everyday intuition, is a tightly packed object, something dense and compact, like a microscopic stone. What you would actually find is something closer to a ghostly architecture. At the center sits a nucleus so small that it is almost irrelevant in size compared to the atom as a whole. Around it exists a vast region where electrons are found, not as solid particles moving along neat paths, but as probability clouds regions where they might appear if measured. The space between the nucleus and these electrons is not filled with material substance. It is space in the purest sense. If an atom were expanded to the size of a cathedral, the nucleus would be a grain of dust at its center. The electrons would be like a few gnats hovering near the outer walls. Everything in between would be emptiness. And yet, this emptiness is repeated trillions upon trillions of times to form what we confidently call matter. This leads to a paradox that challenges human intuition. If atoms are almost entirely empty, why does the world feel solid? Why does your hand not pass through a table? Why does the ground stop your fall? The answer reveals that solidity is not what we think it is. It is not the result of matter being packed together like bricks in a wall. Instead, it is the result of forces interacting across empty space. When you press your hand against a surface, the atoms in your hand do not collide with the atoms of the object. Their electrons never touch. What happens instead is that the electromagnetic fields surrounding those electrons repel each other. This repulsion is extraordinarily strong. It creates resistance, pressure, and the sensation we interpret as touch. What feels like solid contact is actually an invisible standoff, a refusal of electric charges to occupy the same quantum states. This realization reframes the entire physical world. Solidity is not a fundamental property of matter. It is an emergent experience produced by interactions. The universe does not need solidity to function. It only needs forces, rules, and relationships. Matter behaves solidly because the laws of physics demand it, not because it is filled with substance. The emptiness inside atoms is also not passive. It is not dead space. It is governed by quantum fields that fluctuate constantly, even in what we call a vacuum. Energy appears and disappears in tiny amounts. Virtual particles flicker into existence and vanish. Forces propagate through this space instantly at the atomic scale. What we label as nothing is actually an arena of continuous activity. This idea collides violently with common sense. Our brains evolved to navigate a world where objects appear solid, continuous, and dependable. At human scales, this approximation works perfectly. A chair supports your weight whether you understand atomic physics or not. But when we peel back the layers, reality reveals itself to be profoundly different from the story our senses tell us. Consider your own body. You feel whole, substantial, present, yet your atoms are separated by immense gaps of empty space. If all the emptiness were removed and only the nuclei remained, the mass of your body would stay almost the same, but its size would shrink to something microscopic. You would weigh the same but occupy less space than a grain of sand. This thought alone destabilizes the notion of physical presence. Despite this emptiness, structures remain stable. This stability comes from balance, not density. Forces hold particles in precise arrangements. Electrons occupy specific energy levels. Atoms bind together into molecules, molecules into cells, cells into organisms. All of this complexity arises without ever filling the void. The universe builds everything out of almost nothing. This also explains why matter is surprisingly rigid. Electromagnetic forces are vastly stronger than gravity at small scales. When electrons repel each other, they do so with such intensity that it becomes nearly impossible to force them closer together. This is why solid objects resist compression. It is not because there is stuff in the way, but because the laws of physics prohibit certain configurations. The feeling of hardness, then, is a message delivered by force interactions to your nervous system. Your brain interprets resistance as solidity. It has no reason to question this interpretation because it works. But physics does question it, and the answer it provides is deeply counterintuitive. The emptiness of atoms also hints at a deeper truth. Reality is not made of objects, but of patterns. Atoms are patterns of energy stabilized by rules. Matter is organized behavior, not substance in the traditional sense. What persists is not material fullness, but structure over time. This perspective changes how we understand existence. The world is not a collection of solid things occupying space. It is a network of interactions occurring within space. Space itself is not merely a background, it is an active participant in the drama of physics. Without space, forces could not act. Without emptiness, structure could not emerge. Even light reinforces this idea. Light travels effortlessly through vast emptiness, interacting only when it encounters charged particles. The transparency of space is not an absence of reality, but a condition that allows interactions to be selective and meaningful. If space were filled with substance, the universe would be opaque, chaotic, and uninhabitable. When Richard Feynman spoke about atoms being mostly empty, he was not trying to diminish reality. He was revealing its elegance. The universe achieves stability, complexity, and beauty not by cramming matter together, but by arranging emptiness with precision. This is a far more subtle achievement than simple solidity. There is also a philosophical discomfort hidden in this idea. If what we experience as solid is largely illusion, what else might be misunderstood? If our most basic sensory certainty can be overturned by deeper knowledge, then reality may be stranger than we are prepared to accept. Physics repeatedly teaches this lesson. The universe does not care about human intuition. Yet there is also something humbling and inspiring in this truth. From emptiness emerges everything. From near nothingness arises form, resistance, life, and consciousness. The universe does not require substance in abundance. It requires order, and that order is written into the laws governing empty space itself. So when you sit on a chair, walk on the ground, or hold an object in your hand, you are engaging with a grand illusion maintained by forces acting across voids. You are supported by emptiness disciplined by physics. The solidity you trust is real in its effects, but not in the way you imagine it. Atoms are mostly empty space, and yet reality feels solid. This is not a contradiction. It is a reminder that reality is deeper than appearance, that what feels obvious may be profoundly deceptive, and that the true structure of the universe lies hidden beneath the surface of everyday experience, waiting to be discovered by those willing to question what solid really means. Richard Feynman's most unsettling contribution to our understanding of reality was not a complicated equation or an obscure particle, but a shift in perspective so radical that it quietly dismantles how we think the universe works. He asked us to stop focusing on things and start paying attention to forces. Matter, in his view, is almost a distraction. What truly governs the behavior of the universe is not solid substance, but invisible interactions acting across space. Human intuition is deeply materialistic. From childhood, we learn that objects are solid, heavy, and self-contained. A stone is a stone because it is made of something dense. A wall blocks us because it is filled with matter. This way of thinking feels natural because it aligns with our senses. But Feynman insisted that nature does not operate according to how things feel. It operates according to laws, and those laws speak the language of forces. At the atomic level, matter loses its familiar meaning. Atoms do not behave like tiny solid beads. They are dynamic systems governed by electric attraction, repulsion, and quantum rules. What keeps electrons bound to a nucleus is not a physical tether, but an electromagnetic force. What keeps atoms bonded into molecules is not glue, like material, but energy relationships. Remove the forces, and matter instantly dissolves into meaningless components. Feynman emphasized that when two objects interact, nothing material is exchanged in the way we imagine. If you push a box across the floor, it feels like your hand is directly applying force to the box. But what actually happens is that electromagnetic fields from the atoms in your hand interact with electromagnetic fields in the atoms of the box. There is no direct contact, no solid pushing against solid, only forces responding to forces. This realization destabilizes the idea that matter is primary. Matter becomes secondary, almost incidental. What matters more are the rules that govern how particles influence each other across space. The universe is not built like a machine made of solid parts bumping together. It is more like a web of invisible tensions, where every interaction is mediated by fields. Gravity offers another striking example. Two massive objects attract each other across vast distances without touching. There is no rope connecting planets to stars, yet they move in precise orbits. Feynman was fascinated by how absurd this seems when viewed through everyday logic. How does the Earth know where the Sun is? The answer lies not in material contact, but in fields permeating space itself. This insight reaches its most dramatic expression in quantum physics. At this scale, particles do not even behave like persistent objects. They appear and disappear. They change identity. They exist as probabilities rather than locations. What remains consistent are the forces and rules governing their interactions. The universe seems less interested in preserving objects than in maintaining patterns of behavior. Feynman often stressed that the idea of a particle as a tiny solid thing is a convenient approximation, not a fundamental truth. In quantum field theory, particles are excitations in underlying fields. An electron is not a thing sitting in space. It is a disturbance in an electron field that exists everywhere. The field is more fundamental than the particle. The force comes before the object. This flips common sense upside down. We tend to believe that forces act between objects. Feynman showed that it is more accurate to say objects arise from forces. Stability, mass, and structure are consequences of interaction. Matter is what happens when forces balance in just the right way. The sensation of solidity illustrates this perfectly. When you press your hand against a table, you feel resistance. Your brain interprets this resistance as solid matter pushing back. but Feynman explained that this resistance is entirely due to electromagnetic repulsion. The electrons in your hand and the electrons in the table are governed by the same quantum rules, including the Pauli exclusion principle, which forbids them from occupying the same state. The result is an overwhelming force that prevents overlap. Nothing solid is stopping your hand, a rule is stopping it. This is deeply unsettling because it means that physical reality is upheld not by substance, but by constraints. The universe enforces behavior. It does not require material fullness to do so. What we experience as hardness is really prohibition. Physics saying no, with immense authority. Once you see the world this way, many everyday assumptions collapse. A steel beam is not strong because it is packed with matter. It is strong because the electromagnetic bonds between its atoms resist deformation. Water flows not because it is less solid, but because the forces between its molecules allow mobility. Air supports flight not because it is thick, but because pressure emerges from molecular motion governed by force laws. Even mass itself is not what it seems. In modern physics, mass arises from interactions. Much of the mass of protons and neutrons comes not from the particles themselves, but from the energy of the forces binding quarks together. Matter owes its weight to force energy. Substance fades again into the background. Feynman's insistence on thinking in terms of forces rather than objects was not just philosophical. It was practical. It allowed physicists to make accurate predictions, build technologies, and understand phenomena that material-based thinking could not explain. Electronics, lasers, semiconductors, and nuclear energy all rely on manipulating forces, not solid matter. This perspective also humbles human perception. Our senses are not designed to reveal the true structure of reality. They evolved to help us survive. Solidity is a useful illusion. It keeps us from walking into walls. But physics is not concerned with usefulness. It is concerned with truth, even when that truth feels alien. There is something almost poetic in this. The universe is held together by invisible influences acting across emptiness. Nothing touches, yet everything interacts. Stability emerges not from contact, but from balance. Existence is less about possession and more about relationship. Feynman understood that this way of seeing reality demands intellectual courage. It requires letting go of comforting images and embracing abstraction. But he also believed that the reward is worth it. Once you accept that forces are fundamental, the universe becomes more coherent, not less. Its strangeness forms a consistent pattern. In this view, matter is a kind of frozen conversation between forces. Atoms are agreements between attraction and repulsion. Objects persist because interactions maintain equilibrium. Change occurs when forces shift. The universe is not static substance. It is ongoing negotiation. This realization extends beyond physics. It subtly challenges how we think about permanence, identity, and control. If even matter is not truly solid, then certainty itself becomes questionable. What seems fixed may be conditional. What seems stable may be dynamic beneath the surface. Feynman did not see this as a reason for despair. On the contrary, he found joy in it. He believed that understanding the universe as a dance of forces made it more beautiful, not less. The fact that emptiness can give rise to structure through simple rules is a testament to the elegance of nature. When you look at the world through this lens, everything changes. A wall is no longer a slab of matter. It is a fortress of electromagnetic resistance. A chair is not solid wood. It is organized force. your own body is not a container of substance. It is a finely tuned balance of interactions sustained moment by moment. The universe, as Feynman revealed, is not built from things. It is built from how things affect each other. Forces are the grammar of reality. Matter is merely the sentence they form. Once you truly grasp this, the idea of solidity never feels quite the same again. You realize that what holds you up, stops you, and shapes your world is not material contact, but invisible rules acting flawlessly across empty space. And in that realization, the universe becomes at once stranger and more profoundly ordered than you ever imagined. What we call solidity is one of the most convincing illusions the universe presents to the human mind. It feels undeniable. A wall stops you. A stone resists your hand. A floor carries your weight without hesitation. From the moment we are born, we learn to trust this sensation as proof that the world is made of firm, tangible substance. Yet, when physics peels back the surface, this certainty collapses into something far stranger. What you experience as solid matter is not solidity at all, but a carefully orchestrated interaction of forces that your brain translates into touch. At the microscopic level, no object is truly solid in the way our senses suggest. Atoms do not press against one another like tightly packed spheres. They remain separated by empty space, held in position by electromagnetic forces. When you press your hand against a table, the atoms of your hand never meet the atoms of the table. There is always a gap, however small, governed by invisible rules. What stops your hand is not a physical barrier, but a powerful resistance created by the repulsion of electric charges and the strict constraints of quantum mechanics. This resistance is so consistent and reliable that it convinces your nervous system it must be solidity. Your brain does not detect electrons or fields. It detects pressure, deformation, and nerve stimulation. From these signals, it constructs the idea of hardness. Solidity, then, is not a property of objects themselves. It is a sensory interpretation of force. The electromagnetic interaction is the main architect of this illusion. Electrons carry negative charge, and like charges repel each other. When two objects approach, their electron clouds begin to overlap in a quantum sense. This overlap is forbidden by fundamental rules, particularly the Pauli exclusion principle, which prevents identical electrons from occupying the same quantum state. The result is an immense repulsive force that increases rapidly as objects get closer. This force is what you feel when you touch something. What is remarkable is that this force operates across empty space. There is no solid surface doing the pushing. The surface is a region where forces become strong enough to prevent further approach. Your finger stops not because it hits matter, but because physics draws a line that cannot be crossed. This understanding rewires the meaning of physical contact. Touch is not contact, it is communication. It is your atoms signaling to other atoms through fields, and those signals being translated into sensation. Every time you pick up an object, you are participating in a dialogue between charges, mediated by space itself. The illusion of solidity is reinforced by consistency. Objects behave predictably. Floors always support us. Walls always block us. This reliability makes solidity feel fundamental. But reliability does not require substance. It requires stable rules. The laws governing electromagnetic interactions are unwavering. Because they never fail, the illusion they produce feels absolute. At larger scales, this illusion becomes even more convincing. Billions of atoms interacting simultaneously create collective behavior that seems continuous and solid. The gaps between atoms become irrelevant to human perception. Just as a crowd appears solid from a distance despite the space between individuals, matter appears solid despite its atomic emptiness. Yet this illusion breaks down under certain conditions. Extreme pressure can force atoms closer together, altering their behavior. In stars, matter collapses into states that defy everyday experience. In neutron stars, electrons are crushed into protons, and matter becomes so dense that the familiar rules of solidity no longer apply. These exotic states remind us that solidity is not universal. It is conditional. Even temperature affects solidity. Heat is not a substance, it is motion. As atoms vibrate more intensely, the forces binding them weaken. Solids melt not because matter disappears, but because the balance of forces changes. The same atoms arranged differently produce liquids and gases. Solidity vanishes without any change in substance, only in interaction. This reveals a profound truth. Phases of matter are expressions of force relationships. Ice, water, and steam are not fundamentally different materials. They are different negotiations between electromagnetic forces and energy. Solidity is one outcome among many, not the default state of reality. The brain, however, clings to solidity as a psychological anchor. It gives us a sense of stability in a chaotic universe. Knowing that the ground will hold us is essential for survival. But physics is under no obligation to preserve our comfort. It reveals that the ground holds us not because it is solid, but because it obeys laws that make it behave as if it were. Once this idea is internalized, even the act of standing becomes strange. You are not resting on matter. You are balanced on repulsive forces. Gravity pulls you downward, while electromagnetic resistance pushes upward. Your existence in place is a constant equilibrium between competing influences. This balance extends inward into your own body. Your bones feel solid, but they are lattices of atoms held apart by forces. Your skin feels continuous, but it is a structured field of interactions. Even pain, when you touch something sharp, is not the sensation of matter piercing matter, but the nervous system responding to intense force gradients. The illusion of solidity also shapes language and thought. We speak of hard facts, solid arguments, and firm foundations. These metaphors reflect our trust in physical hardness as a symbol of certainty. But at the deepest level, certainty comes not from substance, but from rule, bound behavior. The universe is reliable not because it is solid, but because it is lawful. There is a quiet irony here. The more deeply we investigate matter, the less material it becomes. Solids dissolve into atoms. Atoms dissolve into particles. Particles dissolve into fields. At each step, solidity fades, replaced by abstraction. What remains is pattern and law. This does not make reality unreal. It makes it more subtle. The fact that solidity is an emergent illusion does not reduce its importance. Illusions can have real consequences. A wall can still stop you. A floor can still break your fall. The illusion works because it is built on something real, force. Understanding this changes how we relate to the world. It invites humility. Our senses give us a practical map, not a true one. They show us what we need to survive, not what exists in full detail. Physics fills in the gaps, often at the cost of comfort. It also invites wonder, that something as intangible as an electromagnetic field can create the feeling of hardness is astonishing. That empty space can feel solid is one of nature's greatest tricks. The universe produces firmness without filling itself with matter. Richard Feynman delighted in pointing out such contradictions. He believed that discomfort was a sign of learning. When your intuition breaks, your understanding grows. The illusion of solidity is one of those breaking points, where common sense gives way to deeper truth. In the end, what we call solid is a carefully maintained boundary enforced by invisible laws. It is not a thing, but an effect. You move through a world of forces masquerading as objects. Every step you take is supported by rules you cannot see, acting across space you cannot feel. Once you truly absorb this, the ordinary world becomes extraordinary. A simple touch becomes a quantum event. A solid surface becomes a force field, and the universe reveals itself not as a collection of hard things, but as a beautifully structured emptiness that knows exactly how to push back. When we hear the word nothing, the mind imagines absence, silence, and void. It suggests a lack of substance, a place where nothing happens. Yet the space between atoms, the very emptiness that makes up most of the universe, is anything but inactive. What appears to be nothing is, in fact, one of the most dynamic and influential arenas in existence. The emptiness between atoms is alive with motion, energy, and invisible structure, and understanding this changes how we define reality itself. At the atomic scale, empty space is not a passive background. It is governed by quantum fields that exist everywhere, even in regions devoid of particles. These fields define how particles behave, how forces act, and how energy flows. An electron does not move through empty space like a marble rolling across a floor. It exists as a disturbance in a field that already fills space. Without that field, the electron would have no meaning. This overturns the classical idea that space is merely a container for matter. In modern physics, space participates in physical events. Fields permeate it, fluctuate within it, and shape what is possible. The so-called vacuum is not empty. It is the lowest energy state of these fields. Even at this lowest state, activity never fully ceases. Quantum mechanics reveals that energy can briefly appear in empty space and vanish again, a consequence of the uncertainty principle. These fleeting events are not directly observable, yet their effects are measurable. They influence particle behavior, shift energy levels, and even exert forces. What we perceive as nothing exerts pressure, shapes matter, and affects outcomes. One striking example is the force that arises between two uncharged metal plates placed extremely close together in a vacuum. Even with no particles between them, they experience attraction. This phenomenon arises from fluctuations in empty space itself. The vacuum behaves differently when constrained, producing measurable force. Emptiness responds to boundaries. This tells us something profound. Space is not inert. It reacts. It has structure. It contains potential. The universe is not built on a backdrop of nothingness, but on a foundation of restless possibility. At the scale of everyday experience, this activity remains hidden. The effects are subtle, drowned out by stronger forces and larger motions. But at small scales, the influence of empty space becomes unavoidable. It contributes to the stability of atoms, the behavior of particles, and the nature of forces. Light, too, reveals the richness of emptiness. Photons travel effortlessly through vast regions of space, interacting only when conditions allow. The transparency of space is not a sign of absence, but of order. The fields that fill space allow light to propagate smoothly, preserving information across cosmic distances. If space were truly empty, light would have no medium in which to exist. Even gravity reshapes our understanding of emptiness. According to modern theories, massive objects distort the geometry of space itself. Space is not a fixed stage. It bends, stretches, and responds. Empty space near a massive body behaves differently from empty space far away. Time flows differently. Paths curve. Nothingness acquires shape. This idea is deeply counterintuitive. How can nothing bend? How can emptiness exert influence? Yet experiments confirm these effects with extraordinary precision. GPS satellites must account for them to function correctly. The practical consequences of active emptiness reach into everyday technology. The energy of empty space may also dominate the universe on the largest scales. Observations suggest that an unknown form of energy associated with space itself is driving the accelerated expansion of the cosmos. This means that emptiness is not only active at small scales, but powerful enough to shape the fate of the universe. Such ideas force a re-evaluation of what it means to exist. If empty space carries energy, influences matter, and governs motion, then the boundary between something and nothing becomes blurred. The universe is not divided into matter and void. It is a continuum of fields and interactions. At the human level, emptiness is often feared or dismissed. We associate it with lack or loss, but physics suggests that emptiness is creative. It allows motion. It enables interaction. It provides room for structure to form. Without empty space, atoms could not exist, forces could not act, and complexity would be impossible. The stability of matter depends on emptiness. If electrons were forced into the nucleus, atoms would collapse. The vast space between particles allows forces to balance. Emptiness is what gives matter its shape. It is the silence that makes music possible. This perspective also reframes the concept of isolation. No region of space is truly isolated. Fields connect everything. Interactions extend across distances. What happens in one place can influence another through the medium of space itself. The universe is interconnected through what appears to be nothing. Richard Feynman often emphasized that nature does not conform to human categories. Words like empty and full are approximations, not truths. The universe operates on deeper principles that defy simple labeling. Emptiness is not the opposite of existence. It is a different mode of existence. When we look up at the night sky, we see vast dark regions between stars and galaxies. It is tempting to think of this darkness as absence. In reality, those regions are filled with fields, radiation, and subtle energy. They are not blank pages, but complex texts written in a language we are still learning to read. The more physics advances, the more it reveals that what we once dismissed as nothing is often the most important part of the story. The emptiness between atoms determines the size of objects. The vacuum determines the behavior of particles. Space determines